In your previous lesson, you learned about kinetic and potential energy. Kinetic energy, as an energy in motion, and potential energy, as an energy at rest. There are two kinds of potential energy: gravitational potential energy, and elastic potential energy. Gravitational potential energy is an energy possessed by an object due to height. Today, we will learn about elastic potential energy. Elastic potential energy is energy stored in a string, or any elastic, or stretchable materials. Examples are rubber band, slingshot, garter, and more. To calculate the elastic potential energy of an elastic material, the formula used is P is equal to 1/2 kx squared, wherein K is the spring constant, which is how much Newton of force is applied to stretch an object per meter. The unit is Newton per meter. And x, which is the extension, or compression distance, which is how much distance an object is being stretched. Example problem. A rubber band with a spring constant of 450 Newton per meter is stretched to a distance of 20 centimeter. How much elastic potential energy is stored in the rubber band? Givens are: K is 450 Newton per meter, and x is 20 centimeter. The unit for compression distance is meter, therefore, we need to convert 20 centimeter to meter. 20 centimeter is equal to 0.2 meter. Formula is P is equal to 1/2 kx squared. In solution, substitute the given to formula. P is equal to 1/2 times 450 Newton per meter times 0.2 meter squared. 1/2 times 450 Newton per meter times 0.04 meter squared. 1/2 times 18 Newton meter. The answer is 9 joules. Another example problem. A string with a spring constant of 500 Newton per meter is stretched up to 0.5 meter. How much elastic PE is stored in the string? Givens are: K is 500 Newton per meter. X is 0.5 meter. Formula used: PE is equal to 1/2 kx squared. Solution: PE is equal to 1/2 times 500 Newton per meter times 0.5 meter squared. 1/2 times 500 Newton per meter times 0.25 meter squared. 1/2 times 125 Newton meter. The answer is 62.5 joules. Power. Power is the amount of work applied on an object per unit time. It is the rate of doing work. This can also be expressed as P is equal to W divided by T, wherein P is power, W is work done, unit is joules. T is time, unit is seconds. The unit for power is watt, named after James Watt. Power is equal to work divided by time. Remember that the formula for work is force times distance. Therefore, power can also be expressed as P is equal to force times distance divided by time. Power example problem. A woman exerted work of 150 joules to push a table on the other side 5 meters away, and it took her 2 minutes. How much power is done? Givens are: work is 150 joules, distance is 5 meters, and time is 2 minutes, which is equal to 120 seconds. Formula used: P is equal to work divided by time. In solution, we will only use work and time, therefore, disregard the distance. P is equal to 150 joules divided by 120 seconds. The answer is 1.25 watts. Another example. How much power is done to push a box using 350 joules of work in 5 seconds? Givens are: work is 350 joules. Time is 5 seconds. Formula: P is equal to work divided by time. Solution: power is equal to 350 joules divided by 5 seconds. The answer is 70 watts. Another example problem. A 750 kilowatt lawnmower is used to remove grasses in the garden for 30 minutes. How much work is done by lawnmower? Work is being asked in the problem. To derive the formula for work, use the formula P is equal to work divided by time. The formula for work is simply to multiply power and time. Work is equal to power times time. Givens are: P is equal to 750 kilowatt. Convert kilowatt to watt. 750 kilowatt is equal to 750,000 watts. Time is equal to 30 minutes. Convert 30 minutes to seconds. 30 minutes is equal to 1,800 seconds. Formula. Work is equal to power times time. Solution. Work is equal to 750,000 watts times 1,800 seconds. The answer is 1,350,000,000 joules. Another example problem. If using TV alone for 1 hour uses 5 million joules. How much power is consumed if you use TV straight for 2 days without turning off? How much will it cost if 1 watt is equal to 10 pesos? Givens are. Time is 1 hour. Convert to seconds. 1 hour is equal to 3,600 seconds. Work is 5 million joules. Formula. Power is equal to work divided by time. Solution. P is equal to 5 million joules divided by 3,600 seconds. Power is equal to 1389 watts. Now, if you read the question once again, the TV is used without turning off for straight 2 days. 1 day is equal to 24 hours, therefore 2 days is equal to 48 hours. Multiply 1389 to 48. The answer would be 66,672 watts is consumed for 2 days of using TV alone. Now, how much will it cost if 1 watt is equal to 10 pesos? Multiply 66,672 to 10 pesos. The answer would be 666,720 pesos. In other words, using of TV alone for straight 2 days without turning off would cost 666,720 pesos electric bill. This is just an example. Don't take it seriously.